Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
Welcome to our last question, question 11 of the CSET Math Exam June 2012 video solution. So let's start with question 11A. Question 11A gives us the position vectors of 3 points A, B, and C. And this is it. Vector OA, the position vector of A, is 6, 2. Vector OB, the position vector of B, is 3, 4. And vector OC, which is the position vector of C, is 12, negative 2. And firstly, they're asking us to calculate the displacement vector BA. Now, the displacement vector BA is given by OA minus OB. That's O times the last minus O times the first. A being the last and B being the first. So displacement vector BA is OA minus OB. And so we can go ahead and show that OA is 6, 2 minus OB, which is 3, 4. And so that reduces to 6 minus 3 is 3, 2 minus 4 is negative 2. And therefore, the vector BA is 3, negative 2. Next, we're asked to calculate the displacement vector BC. And so, the displacement vector BC is given by O times the last, which is OC, minus O times the first, which is OB. Vector BC is OC minus OB. And that is OC, which is 12, negative 2 here, minus OB, which is 3, 4. And therefore, the result is 12 minus 3 is 9, negative 2 minus is negative 6. And we can observe that vector BC is actually 3 times 3 to negative 2. What we have done is factorize this 9, negative 6. And so BC, vector BC is 3 times 3, negative 2. Now we did that in order to compare vector BC with vector BA, because section 2 is asking us for geometric relationships between BA and BC. So we factorize this vector BC into 3 times the vector 3, negative 2. And since BA is 3, negative 2 here, we see that the vector BC is actually 3 times the vector BA. And we can go ahead and show that. The vector BC is 3 times the vector BA. This means that vector BC is parallel to vector BA. Once one vector is a multiple of the next, it means that the two vectors are parallel. And if we want to compare the length of BC with the length of BA, we have to take the modulus of both sides. So taking the modulus of both sides, that will remove the vector component, and so we end up with BC being equal to 3 times BA. This means that the length of BC is 3 times the length of BA. So let's move down to part 2. Now what we have so far is the position vector of the 3 points, and that the vector BC is 3 times the vector BA. That's our vector equation. And then the length of BC is 3 times the length of BA. This is a scalar equation. Now we're asked in part 2 for a geometric relationship between BA and BC, and part 3 is asking us to sketch the position of the points A, B, and C. We'll do part 2 here, and we'll do part 3 on this side. Now when we're asked to state the geometric relationship between two lines, we have to say whether or not the lines are parallel, and we also have to give the relationship between the length of the two lines. Now here we have a vector equation where one vector is a multiple of the next, and that vector equation means that the lines are parallel. This is a scalar equation stating that the length of BC is 3 times the length of BA. So we can use these two equations to deduce the geometric relationships between BC and BA. So let's go ahead and show that. Now the first equation, which is a vector equation, means that BC is parallel to BA. And because B is a common point, it also means that the points A, B, and C are collinear, meaning they are on a straight line. And that is what we can deduce from this first vector equation. The second equation, which is a scalar equation, means that the length of the line BC is 3 times the length of the line BA. And that's what we have here. So that's the relationship between BA and BC. The lines are parallel. BC is parallel to BA, and because B is a common point, it means that the points A, B, and C are collinear. That is what we deduce from this vector equation. And then from this scalar equation, we have deduced that the length of the line BC is 3 times the length of the line BA. Let's now go and do the sketch. Now, because we have the position vector of the points A, B, and C, we can deduce the coordinates of the points A, B, and C, because the coordinates will have the same values as the position vectors. So because the position vector of A is 6, 2, it means that the coordinate of the point A is 6, 2, written like this. And because the position vector of the point B is 3, 4, column vector of 3, 4, it means that the coordinates of the point B is 3, 4, written like this. And then because the position vector of the point C is the column vector 12, negative 2, it means that the coordinates of C is 12, negative 2 as shown here. And we can go ahead and show the graph and put those points in. And so A is a point 6, 2, that's here. B is a point 3, 4, that's right here. And C is the point 12, negative 2. So that is the point C. Then we can go ahead and show the vectors. So this vector O to A is the vector OA here. And then the line from O to B is the position vector of B. That's vector OB. And then this line here is the vector OC. That's the position vector of C. And then we can also show that A, B, and C are collinear. That's a straight line passing through the points A, B, and C as we deduced here. And also we can see that BC, the length of BC, is 3 times the length of BA. So this diagram is reflecting the geometric relationship between BA and BC, and also showing that the points A, B, and C are collinear. And that's the answer for part A. Let's now move down to part B. Now part B is telling us to find the value of A and B such that this product is equal to this. Now the 2 here will be obtained by multiplying this row by this column. This 0 will be obtained by multiplying this row by this column. This 0 is obtained by multiplying this row by this column. And this 2 is obtained by multiplying this row by this column. But what we can do is focus on how this 0 was obtained and also how this 0 was obtained. And that will allow us to find our A and our B. And this is it. This 0 is obtained by multiplying row 1 by column 2. That is this row by this column. So we can go ahead and show that. Row 1 multiplied by column 2 is equal to 0. And this 0 is obtained by multiplying row 2 by column 1. That is this row by this column. And so we can show that row 2 multiplied by column 1 is equal to 0. So let's do the calculation down here. And this is it. Row 1 multiplied by column 2 is 0. That is row 1, which is A negative 4 here, multiplied by column 2, which is negative 4, negative 3 down here, is equal to 0. And so we can carry out this calculation. This multiplied by this plus this multiplied by this is equal to 0. Let's show that calculation. That is a multiplied by negative 4, that's negative 4a, and negative 4 multiplied by negative 3, that's positive 12, is equal to 0. And so if negative 4a plus 12 is 0, it means that a is equal to 3. And then on this side, we are multiplying row 2 by column 1, and the result is 0. And this is it. The second row multiplied by the first column is equal to 0. That's what we have here. So it is the row 1b multiplied by the column 2(1) is equal to 0. And so 1 multiplied by 2 plus b multiplied by 1 is equal to 0. So let's show that. And that is it. 1 multiplied by 2 is 2. B multiplied by 1 is b. And the sum of those two is 0. So if 2 plus b is 0, it means that b is equal to negative 2. And that's it. We have calculated the value of a and the value of b. And that's our solution. A is 3 and b is negative 2. And we can therefore show the value of a and b in the matrices equation that we were given. And this is it. So let's now move down to part 2. Now in part 2, we are being asked to find the inverse of this matrix. And what we have is this matrices equation. Now if we can adjust this matrices equation to produce the identity matrix here, then we would have created a situation where we have a matrix multiplying by its inverse, because we know that the product of a matrix and its inverse is equal to the identity matrix, which is 1 0 0 1. That is the identity matrix. So if we can adjust this matrices equation such that we have the identity matrix on this side, then what we would have is the product of the inverse of a matrix and this matrix. That adjustment can be made simply by multiplying both sides of this matrices equation by a half. So let's go ahead and show that. If we multiply this side of this matrices equation by a half, we would produce the identity matrix, and so we would have to also multiply this side by a half. So let's show that calculation. If we apply the half on this side, we would have generated the identity matrix, and therefore this is the inverse of this matrix, which is what we're required to find, because we know that the inverse of a matrix multiplied by a matrix is equal to the identity matrix, and therefore this matrix is the inverse of this matrix. And so we can write that solution. Because this is the identity matrix, it means that the inverse of this matrix, let's call it M, the inverse of this matrix is equal to this matrix. And that is the answer for that part. Let's move down now to part 3. Now in part 3, we are told to use the inverse matrix of this M to calculate the values of X and Y. And let's show how this calculation is done. This is a matrices equation, and we need to find the values of X and Y. Now we must recognize that what we have here really is M multiplied by the matrix XY equals 12 7. And if we go ahead and multiply both sides of this matrices equation by the inverse of M, we produce this matrix equation. Now remember that a matrix multiplied by its inverse is the identity matrix. So M to the minus 1 multiplied by M here will produce the identity matrix. And that is it. And then the identity matrix multiplied by this matrix is equal to this matrix, because the identity matrix is just like the number 1. And so this is the result of this transposition. And it obeys the basic matrices transposition, that if matrix M multiplied by XY is equal to 12 7 here, then the matrix XY is equal to the inverse of M multiplied by 12/7. So by substituting the inverse matrix here and carrying out this calculation, we can calculate the column matrix xy and therefore the value of x and the value of y. So let's show that calculation. And this is it. The matrix xy will be equal to the inverse of m, which is this matrix here, multiplied by 12/7. And when we carry out the calculation, we will end up with a column matrix, and we have placed the codes here to show how this calculation is done. This element here will be obtained by multiplying this row 1 by this column 1, and this element here will be calculated using row 2 column 1, that is the second row of this matrix, multiplied by this column matrix. And so we can go ahead and show that calculation. This element is row 1 column 1, meaning we multiply this row by this column. So we're multiplying 1.5 by 12, that's here, and we are multiplying -2 by 7, -2 by 7, and the result here is 4. And then for this element, we are multiplying row 2 by column 1. So we multiply 0.5 by 12, and we multiply -1 by 7. And when we do that calculation, the result is -1. And therefore, x is equal to 4 and y is equal to -1. And we can therefore show our solution line. The solution is x equals 4, y equals -1. And that's the end of this question. And that's the end of this production. I hope you learned a lot.
Daddy, you're recording mathematics the easy way for me?
Yes, Kai, but you have to be quiet. Remember, you have to be quiet when I'm recording this stuff, okay?
Yes, Daddy.
And we'll continue to do more video solutions in the future.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.